Howdy HL Math, this is Miss Kosh. I want to talk you through this activity. I'm going to do it all in one video, or try to, but I want you to pause and then work, and then come back and hear the next part. And then when I tell you to pause, I want you to pause it and then come back. This is definitely a discovering sort of thing. I want you to work through it and to have that aha moment and not just have me hand it to you. So the first thing, what we're looking at, is I've given you two quadratic, number 1 and number 2, I've given you two quadratic equations, and I want you to find the roots. So on both of those, I think they factor rather nicely. Find the roots and then add the roots together and then multiply the roots together. Okay, and then over here, I want you to add the roots together and multiply the roots together. Same idea. So this is a quick little refresher on quadratics, and then what happens is there's some sort of pattern that's going on when you add the roots and multiply the roots. So pause the video here and do number 1, number 2, and even number 3. Okay, so at this point, pause. Make sure you've done number 1, 2, and 3, and then come back to get the rest of the plan. Okay, you paused it. Good. Now you're back. And so what we want to do is on the next one, this is a chance for us to do a proof. So IB is really big into proofs. And so what they want you to do is they want you to prove what you just, so that, if you were confused before, that conjecture is, okay, what do you think is happening? Can you write a rule? Can you write a formula? Can you make a guess as to what's been going on in these previous, what did these examples lead you to believe? Okay, that's your conjecture. And then in part 4, you are going to actually prove that conjecture. Okay, so they gave you this nice little hint. And so what you want to do is you want to FOIL out this, to multiply that side all together. And so when you do, you have k times, what does that become? X squared minus r2x minus r1x plus r1, r2. And this would be equal to, so what you're going to do, all I did was FOIL that first one. You're going to manipulate this until you come down to something interesting. So I want you to keep, basically we just FOILed, I want you to try and see what you can come up with. Pause right here, and then come back and watch and see what happens. Okay, so hopefully you paused and you tried to get the proof done. I'm going to go ahead and finish this for you. This becomes kr squared, and then this right here, I can factor out an x for the next two terms, and I can factor out that k, well, so this becomes plus, let's say k time, you know what, hang on. Oh, that's too many parentheses. Okay, so then it becomes a negative r1 minus an r2 times an x, and then plus k times r1, r2, and that's equal to, you know what, this is going to bug me. Oh, there we go. Okay, that's equal to a2x2 plus a1x. The a2x squared is what I should have said, my bad. It's too early in the morning. Okay, so what we find here is that our a2 value is exactly equal to k. So then the next one, our a1, so notice I like yellow to begin with, I took this, the x squared term, and I set it equal to the x squared term. Well, so that means that our a2 is equal to k. And then I can look at, okay, well, what's the x term here? What's that equal to? And so we have that, that a1 is equal to k times a negative, let's factor out that negative. Hang on, I'm going to write that better. We'll factor it out over here. A negative k times an r1 plus an r2. But we just said that k is equal to a2. And so what we have is that we have a1 is equal to a negative a2 times the product of our roots. Yes, the sum, not the product. Oh my goodness, I'm so sorry. It's too early in the morning. I need more coffee. Let me try that again. We have a1 is equal to a negative a2 times the sum of those two roots. So therefore, this implies that the sum must be equal to A1 over A2, and somewhere you're going to have a negative. Okay, likewise, then now we have, I need another color. I don't like orange. That's the Aggie in me. We don't like that other school's colors. So this, our A0 would be equal to K R1 R2. Now notice this is the product of the roots. I'm finally saying the correct thing. A1, I lied. K is still A2. And so this is A0 is equal to A sub 2 times R sub 1 sub R sub 2. So the product, R1 times R2, is equal to A sub 0 divided by A sub 2. Basically, here's what's happening. What we found is that the, let's go with this. What we found is that the product of the roots is the constant divided by the leading coefficient. And then what we found, and what we also found, is that the sum of the roots is equal to the negative of the middle term divided by the leading coefficient. Okay, and so that's what we're trying to prove on this first one. Now we're going to move into other polynomials. So with this, what we need to do is same idea. So on this first one, I don't mind if you use on these first two, if you use your calculator to help you find the roots. Go ahead, we're going to pause the video here. We're going to go ahead and try this on our own. And then we're going to make a conjecture then about the sum and the products, just like we did a second ago. And we're going to prove that. I want you to try this on your own. Hit pause. I want you to prove that just like you proved number 4 before. Okay. By the way, here are the answers. Oh, my bad. Here are the answers to that first one. And then there's my little proof. So I do have the answers to the next one. Actually, okay. If you have tried all of the cubic, hit pause if you haven't. Go try it yourself. Now, if you're back, here, let me show you what I had done before. Okay, so I found that the roots for the first one were 3, -2, -1, and therefore the sum was 0 and the product was 6. And then I found that the roots for the second one were -3, +3, -2. The sum was -2. The product was 18. And so, what did I say? Don't forget part 1. I guess it was helpful to kind of remember what we saw with the quadratics. That's always helpful. And so what we are able to do is we're able to say, we're guessing that it's the second term, the coefficient of the second term divided by the first term, and we need to make that negative. And then the product becomes a negative, well, in this case, it became a negative constant divided by the leading coefficient. Well, so here was my proof. So I foiled everything out. It got a little tedious. Hopefully you tried to work through this on your own. I think that that's an important skill for HL Math. And then what we do is we can extend this out. Let me just stop here. We can extend this out to this Vieta's formula. I don't know how to say that, but pretend it's something like that. And this actually, it wasn't in the IB formula book before, but it is now. Okay, so they give this to you. But what happens is that the sum of all the roots, no matter how big the polynomial is going to be negative. It's the negative second coefficient divided by the first coefficient is the sum. And then the product, you have to take -1 and raise it to the n power. So if it's a quartic with a degree of 4, then it's going to be positive because I'd have -1 to the 4th power, and then this would be a positive. But then this is the constant divided by the leading coefficient. So this, luckily for you, is in the formula booklet. So then the next thing, and this is worth writing down and writing it down every time. Maybe you'll get it memorized. I don't have it memorized, but now it's in the formula booklet, so it doesn't matter. I have to kind of go look for it every time. So then there's a few problems that they want you to work. It says find the sum and the products of the roots. Use this is IB's way of saying calculator. It's a graphic display calculator, something like that. to verify the roots. So they want you to use these formulas from here, and then use that to find the sum and the difference. Then go ahead and check finding the roots in your calculator. And then this is more of the same. The problem that's pretty fun. Now I want you to do these, and then you can come back and check your answers. The problems that are fun are something like these two. So let's let you try those. Hang on just a second. Oh. The roots of this equation. Oh, okay. So from part A, you're going to find the sum. You're going to find the sum of, well, the roots now they're saying in part B are alpha plus beta, and then alpha minus beta, because that's an arithmetic sequence. They're in order. We haven't talked about arithmetic sequences yet, my bad, but basically when we add and subtract the same amount each time. But if you've taken pre-cal, you should already know that. So you found back up here, you found the sum of the roots, and then you found the product of the roots. Well, what we know here is that we've got the sum of the roots is going to be alpha plus beta plus alpha minus beta. Those roots aren't in order. This one, maybe I should have done it this way. Anyway, whatever. That was the first one. If you put them in sequential order, that sum is going to be equal to whatever you found up here for the sum. And then we can take the product. Well, notice when we take the product, by the way, this would be, this is the betas cancel, and this is just 3 alpha is equal to whatever that sum is. So that makes it pretty easy to solve for alpha. On the next one, you're multiplying alpha plus beta times alpha minus beta. And what do you notice? Hopefully you notice that this is alpha times alpha squared minus beta squared. And so that gets a little more simple, and then you should already know the alpha here. So go finish this. I'm sorry. I want you to try that. And then number 5 is a good problem also. So this one, here's the sum, and here's the product, and they're put together in an equation, and you need to try and find alpha. So hit pause, go try all of these problems, and I'm going to show the answer key and not talk about it, just in case you don't have access to my answers. So let's see. Here were the answers to number 1, 2, and 3. Yep. Okay, here's 4. And here's 5. Go try these and let me know if you have questions.